Hello everyone, today we're going to be doing a couple of examples using the multiplication rule, and let's go ahead and dive into the first example. A burger joint offers 2 types of patties, 3 types of cheese, and 2 types of buns. How many ways can you construct your burger? Okay, so the assumption here is that we're only talking about the patty, you are getting cheese, and a bun. We're not talking about lettuce, tomato, ketchup, mustard, whatever other toppings. We're only talking about these. And what we're going to do is sort of hopefully work this out in a way that illustrates a little bit of why the multiplication rule works. Okay, so first of all, multiplication rule says that because, right, we've got 3 options, right? The patty, the cheese, and the bun, we can just multiply the number of options here. So that's 2 options for the patty, 3 options for the cheese, 2 options for the bun. 2 times 3 is 6, 6 times 2 is 12. So we should get 12 different ways we can construct this burger. But let's sort of map this out in a more visual way that really illustrates what those 12 options are. Okay, so we're picking a burger, and we have 2 options for the patty. Let's assume that we can get a beef patty or a veggie patty. Maybe are those 2 options. And then for each of those 2, we have 3 cheese options. So for those 2 each, there's 3. So that's where that 2 times 3 comes from. And let's say that our cheese options are cheddar, pepper jack, or Swiss. So we have cheddar, pepper jack, or Swiss. And then for each of those 6 patty cheese combinations, we have 2 options for the bun. So let's say that our options for the bun are wheat or sourdough. Okay. So for all 6 of those, well, there's 2 possible options for everyone. So that's why we take that 2 times 3 and multiply it by 2 again. So wheat, sourdough, wheat, sourdough. Okay, so now we've mapped out all the possible options, right? So for instance, beef, cheddar, sourdough is an option, veggie, cheddar, wheat is an option, veggie, pepper jack, sourdough is an option. Every possible combination is listed out in this tree, and none of them are listed twice. And we can count the number of options at the end: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So mapping it out this way, we get that same answer that we got using the multiplication rule. This way is just more visual and takes longer and is going to be sort of impossible to do for larger examples. But if you understand the principle of why it works, right, for every 2 options here, we've got 3 for the cheese. For now that's 6 total. For every 6 there, we've got 2 options for the bread. That gives us 12. If we understand that principle, we can compute sort of larger examples like our next one. All right. A state's license plate numbers are 7 characters long, and the first 3 are letters and the last 4 are numbers. How many possible license plates are there? Okay, so what we're going to do, just like we did above with the 3 spots for patty, cheese, bun, we're going to make up the 7 spots here. So we have 7 blanks in this license plate number. The first 3 are letters, and we're just assuming regular old alphabet A to Z. The last 4 are numbers. And there's no restriction, so we're going to assume that we can go from 0 to 9. And so what we're going to do here is we fill in the number of options for each one. Well, there's 26 letters, and there's no mention of like repeats, restrictions about that, so we're going to assume repeats are fine, right? We could do A, and that would be okay. So every one of these first three can be A to Z, and that's 26 options each one. And for the numbers, we want to be careful here because it's 0 to 9, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, that's 9 options, plus 0 is 10 options. So we need to be careful to make sure that these are 10 because we're including 0 as a possible option. All right. So you can see this is going to be a pretty big number. It would be almost impossible to draw a tree out like we did in the last example. But we can use the same principles to get the answer here as well. So there's a couple of ways we can write out this answer. We could write out as 26 to the third power, because we've got 26 times itself 3 times, times 10 to the fourth power, because we have 10 times itself 4 times. We could also just go ahead and multiply that out. And when we do, we get 175,760,000. And like I said, almost impossible to draw that tree out. But we can use the multiplication rule to arrive at the number of options that we've got pretty easily. That is it for today.